Hello guys, welcome to my new video, and in this video I'm going to give the solution of computer science paper that has been uploaded by ISC. So without any further ado, let's begin. So this is the computer science paper and we're going to solve part 1 first. The very first question is state associative law and prove it with the help of truth table. So as that we all know associative law states that P plus Q plus R is equals to P plus Q plus R, and the second law is that P dot Q dot R is equals to P dot Q dot R. So this is associative law. Now we're going to make truth table. So we can take three variables PQR 0 0 0 0 1 1 1 1 0 0 1 1 0 0 1 1 0 1 0 1 0 1 0 1. Alright, then we have to then make P plus Q, and we know that P plus Q gives value 1 when any of the term is 1, so it will give 0 0 1 1 1 1 1 and 1. Now we need Q plus R, again doing same 0 1 1 1 0 1 1 and 1. Alright, and now we need P plus Q plus R. That means we're gonna consider this column and this column. Again the sign is addition, then it will give 1 if any of the term is 1. 0 1 1 1 1 1 and 1. Now we need P plus Q and R. So P plus Q and R. So again doing the same, taking this column and this column. It will give 0, then 1 1, again 1, then 1 1 1 and 1. Now we have proved the first law. As we can see, these two terms are identical. Similarly, we can prove P dot Q dot R, which is equals to P dot Q dot R. I'm sorry for mistake here. So this is associative law. Now we're going to see our next question, which is draw truth table to prove that propagational logic expression. So I'm going to show you this expression. We have to prove x log arrow y arrow x equals to x. So this sign is of dot, or we can say it is OR gate, and this is conditional. This sign is for conditional and this is biconditional. So we can represent this as x. Before coming to that, let's remember one thing, that x belongs to y. Have a close look. Can be written by x bar plus y, and x biconditional sign y can be represented as x dot y bar plus x bar dot y. So applying this here, so we can write it at x bar plus y dot y bar plus x equals to x dot y bar plus x bar dot y. Alright, now we're gonna make a truth table. X and y 0 0 1 1 0 1 0 0 1. Now we're gonna make x bar and y bar, it will be 1 1 0 0 1 0 1 0, then x bar plus y, and we're gonna need y bar plus x. This sign gives value 1 when any of the term is 1. So we need this block and this block. It will give 1 1 0 and 1. Now we're gonna consider this and this. It will give 1 0 1 1, and now we're gonna need OR symbol here. Now OR symbol gives output 1 when both the terms are 1. So it will give 1 0 0 1. So this is our left hand side. Now for the right hand side, we need table of x dot y bar plus x bar dot y. So we're gonna again make x and y 0 0 1 1 0 1 0 1, x bar and y bar 1 1 0 0 1 0 1 0. And if you know the truth table of biconditional is 1 0 0 1, you can solve it and you will get this one here. So this is our RHS. So this RHS is equals to LHS. So hence it is proved by truth table. Next Boolean equation AB dash plus BC dash plus 1 equals to 1. Before coming to that question, let us remind that in dual the AND is replaced, OR is replaced by AND is replaced by OR, 1 is replaced by 0, 0 is replaced by 1. So our expression is A B bar plus B C bar plus 1 equals to 1. So we can write it as OR, then B dot. So we can write it as A plus B bar dot B plus C bar plus 0 equals to 0. So this is our dual expression. Let's see next question. Our next question is convert Boolean expression f y z x y z equals to x bar y bar z plus x bar y z bar plus x y z into its cardinal form. So we can write our expression f x. I'm going to write this expression x comma y comma z equals to x bar y bar z plus x bar y z bar plus x y z into its cardinal form. So cardinal form is the form in which the equation is represented by pi or sigma. Alright, so this is POS form. This is SOP form, sum of products. Alright, so SOP is represented by pi. In SOP, x bar is 0 and x is 1. So we have x bar means 0, y bar 0, z without bar means 1, plus x with bar 0, without bar 1, with bar 0, plus without bar all the terms 1 1 1. Now we are going to convert it into binary. So this will be 1 into 2 to the power 0. So this will be 1, and then this will be 2 into 1 into 2 to the power 1. That will be 2, and it will be 1 plus 2 plus 4, that is 7. So the answer of this expression will be pi 1 comma 2 comma 7. There is another alternative to solve this question, that is by making a table, that is a binary table, in which we used to take three terms, then we're going to make like this, and 0 1 0 1 0 1 0 1. This is a time taking process, and you can as see 0, it represents 0, it represents 1 2 3 4 5 6 7. This is 1, as you can see, this is 2, as we can see here, and this is 7. So sigma 127 is the our next question is minimize f xy xy bar xz bar plus xy bar z using Boolean laws. So we're gonna write it xy plus xz bar plus xy bar z. Now this is sum of product, that is SOP, and in SOP we used to multiply the missing terms by 1. So as we can see, there are total 3 terms, and here there are only 2 terms, and here also there are only 2 terms. So first of all, separate the terms which are separable, like xy bar is not separable, but simplifying this by using De Morgan's theorem, x bar plus z bar plus xy bar z. 3 terms, this is fine. There are only 2 terms, so we're going to multiply by 1 only once. They are missing 2 terms, so we're going to multiply twice by 1, again twice by 1 plus xy bar z. Remember that 1 is equals to x plus x bar, or 1 is equals to y plus y bar, or 1 is equals to z plus z bar. That is multiplying a term with its complement, sorry, adding a term with its complement give 1. So z is missing, so we're going to do multiplying with z plus z bar plus again y, then for z, and in this we're gonna do for x, then for y, then z, and then by doing this. So you have to open all these brackets by using distributive law, and then you're gonna simplify it. Let's do it. Xy bar z plus xy bar z bar plus x into y into z, x bar into y into z, x bar into y into z bar, then x bar into y bar z plus x bar into y bar into z bar. Then simplifying this bracket here, x into y plus z, sorry z, plus x into y bar z plus x bar y z plus x bar y bar z and x bar y bar z. Then we're gonna watch for common terms, that is xyz, which is not repeating, so we're gonna write it here, x y bar z, x y bar z, x y bar z here and here, so we're gonna write it like this, and here also x y bar z, x y bar z bar, x y bar z bar, no repeating, so we're gonna write it like this only. Then x bar yz, x bar yz here, x bar yz here, so we're gonna write it like this. Then x bar yz bar, x bar yz bar, since it is also not repeating, so x bar yz bar, x bar y bar z, x bar y bar z here and here, plus x bar y bar z, and then the last term plus x bar y bar z bar. Now see, we can see that this is its complement is here, and as we all know that p plus p bar complement gives you, and this gives you 1. Alright, so solving this will give you 1. Now we can see that here is x, y, y bar, z. Now in this we're gonna take x, y bar as common. We can get z plus z bar. Alright, then let me make this clear to you. This is stack, this is queue. Okay, suppose this is stack. Alright, we're gonna put something things like there, like this, or things or data types. So it works on the principle of last in first out, that is LIFO. The data which is going first will come last, and the data which is going at last will come first. And in queue, if we give a data like data first, it will come out first. So this works on the principle of first in first out. So that's the major difference. Then the next question is convert the following infix to postfix. Okay, postfix b by c by e plus f. In postfix expressions, the symbols are moved forward, so we can solve it like this: b, c, moving it forward, first solving the bracket, then e plus f, then solving this a into bc dash e dash plus f, then solving this a b c bar e bar multiply plus f, then solving at this will give you a b c e f plus. So this is your final postfix expression. Now the next question is define interface, how it is different from class. So Java does not allow multiple inheritance, but it can be used by creating interfaces. An interface defines a protocol or behavior. Its aim is to dictate common behavior among objects from various classes. And classes are inherited by using keyword extend, but interfaces are inherited by using keyword implements. Okay, and a single class can be inherited using extend keyword, but a number of interfaces can be inherited by using implement. So that's the major difference. Now our next question is, each element of array 15 and 20 requires w byte of storage if address of array 68 is 4440 and its base address at ARR11 is 4000. Find W, and when array is stored as column measure wise. So first remember the column measure wise formula. ARR1, ARI and J is B plus W, that's base address plus bytes into I minus lowest row into number of rows into I minus LC. This is the formula, and let's see what is given to us. We are given address, of 68, that is 4440. All right, and we are given base address of ARR 1, 1, that is 4000. So according to this formula, the address equals to base address and I. So here the value of I is 6 and lowest row is 1, number of rows 15, then 8 minus 1. So this is our final expression. Sorry, we have to add w here. Oh, almost forgot it. So after solving this, the value of w will be 440 upon 110. That will come out as 4. So this is our answer. And next question is define big O notations. Right? Big O notations. It is generally used for computing the performance. It is a function with parameter n. While determining the performance of an algorithm, we have to only consider the term which plays a vital role and affects the performance of the function. Such term is known as donating term. So this is definition of big O notations. Alright, and another question is define two factors which determine the complexity of an algorithm. So the two factors are time and space. And our next question is an output based question. So let's do this. A function is given and the value is 4. So void test int count equals to 4. Okay, see if count equals 0, no, 4 is not equals to 0, so it will go in else statement and it will print by and the value